All right, let's take a look at graphing this particular function here. We've got sketch the graph of y equals 3 cos of x minus pi on 4 plus 2. And that's within the domain of 0 and 2 pi. Just a very quick recap. A cos curve. Oops. No, I don't want to stop recording. A cos curve between 0 and 2 pi has a domain of -1 and 1. And we know it has, at pi, it has a minimum of pi. So let's go ahead and just do this. So all right, that's a cos curve. And so what we're asking is, looking at the changes that we've got here in the A, B, C, and D position, what is going to happen to this curve here? Is it going to go up? Is it going to go down? Is it going to go to the right? Are all of these coordinates going to, expand, right, vertically? So what's going to happen to it? Well, let's just go ahead and find out. So looking at each position, we know that this is the A position, this is the B position, this is the C position, and this is the D. And by now, we should know what each of those positions mean. And so the A position, right, is amplitude. So we know the amplitude is 3. That's the distance from the peak to the middle, or from the bottom or the minimum to the middle. And that's 3. And that tells us the vertical expansion. So we know, therefore, we have a vertical expansion by a factor of 3. All right, moving on. Our B position is just 1. So we know already that our period, or our horizontal expansion, that's just going to be 2 pi. So just like the normal cos x curve, nothing will change. It won't be horizontally expanded. We'll just write it though. So our period is just going to be equal to, well, it's going to be 2 pi. And the reason why is because the period is actually 2 pi divided by the coefficient of that x, right? Which is the B position, right? So this here you get by looking at what the coefficient of x is. And seeing as it's 1 here, well, the period is just going to be 2 pi. So therefore, we have a I suppose we don't really have. Therefore, we have no horizontal expansion. That would be compared to cos of x. Okay, let's move on. We've got now our C position. And what does C stand for? Well, that's our horizontal shift, or phase shift. We call it phase shift. So our phase shift, it is equal to, in this particular case, it's equal to -pi on 4. Now, generally what happens is our phase shift is actually, right, if we just call it, I suppose we'll call it in the C position. So to find out what that is, it's actually C divided by B. So let's go ahead and think about that. So we know our C is -pi on 4. It's actually -pi on 4 divided by whatever B is, which is right here. So seeing as it's 1, well, it's just going to be -pi on 4. So that's our phase shift, right? And what is phase shift? Again, it's horizontal shift. But where's it going? Just like in other functions, because it's negative, it will go to the right. So we'll have a horizontal shift, pi on 4 units. And let's indicate the direction now, because we have a negative sign here. That'll indicate that it's going to the right. All right, that's our phase shift. Our last but not least is this. That's in the D position, and that tells us our vertical shift. Now we can just simply look at our vertical shift and just tell in which direction is our graph going or our function going. It's just going upwards 2 units. There's no formula involved. It's just whatever that number is. So we can just say that the vertical shift is 2 units, and then indicate the direction upwards. It's upwards because, well, it's positive. All right, so they're the things that we know. I'm going to group everything a little bit closer together so that we can actually have some room to graph it. Okay, I'm going to set up a bit of a Cartesian plane, or our graph parameters. And I know that our domain is in between 0 and 2 pi, so I'm going to write that. So 2 pi at the very end, 0 here. Now, traditionally, I would write a 1 here and a -1 there. But we know that's not going to be the case. And how do we know that? Well, let's think about it. We've got an amplitude of 3. That means everything will expand by a factor of 3. So knowing that our general cos of x curve goes up to 1, right? Because that's what we normally do, right? See how it's got a maximum of 1 there? We know that that's going to expand by a factor of 3 because that's what it has here. It's going to expand by a factor of 3, and then it's going to go upwards by 2 units. So it's going to go up to 3, and then add 2, it'll go to 5. So that's 5 there. All right. So that's going to be our absolute maximum that we're going to go to. So I'm going to draw a line here just to represent the maximum. So we can't go over that line. And what about our minimum? Well, let's think about this one. Notice how we went from 1, we went and multiplied by 3, which took us to 3, and then we added 2 more, which took us to 5. Well, the same thing is going to happen down below. So starting at -1 here, if that was -1, we'd go and multiply by 3, which would make us -3, right? That's -3 right there. And then to add 2, we don't go in this direction. We actually go in that direction, right? Because we're adding, we're getting closer to 0, we're getting larger. So from 3, we add 2, we actually end up in the same position as the general cos curve. So let's review that again. Our cos curve had a range of 1 to -1, right? And looking at the negative part, we had to multiply by 3. So we multiply by 3. 2, 3. Oh, sorry, that was a mistake. Multiply by 3 just takes us to -3. So there it is there. And then we add 2. We're back at the same position. Okay, so it's at -1. Let's go ahead and put our domain there. And I think what might be helpful is if we kind of label our y-axis here. So that can be, -5. And let's go to -1, -2, -3, -4. And that can be -5 down the bottom. So if that's the case, we probably need to move our range just a little bit out part there. And then that can be 1, that can be 2, that can be 3, that can be 4. Something like that. I'm happy with that. Let me just shift this. All right. So there are parameters for how, where our cos curve is going to fit. All right. So let's have a think about the next part that we can look at. We've kind of ticked off our amplitude and we've ticked off our vertical shift. Our period is going to be just completely normal, just like a normal cos curve. So we could start doing it. Here's the thing. It's our phase shift that we really need to think of. Let's have a think about our phase shift. We know that we have a horizontal shift of pi over 4 units. So instead of starting right, instead of starting like this, just like a normal cos curve, right, that curve here, right, this one right here, is going to shift every part of that, even at the top there, it's going to shift pi on 4 units. So everything about this curve is going to shift, right? It's going to shift completely. All right, so let's think about our x-axis then, so we can set it up. If that's 2 pi on the end, or this would be, you know, pi. This would be pi on 2. This would be 3/2 of a pi. And then in the middle there, between 0 and pi on 2 will be pi on 4. And that's convenient because that's what we're really interested in. We're interested in this because we have a shift of pi on 4 units. So traditionally, where we'd have our cos curve starting from here, working our way down, our minimum at pi, right? And then starting back up again at 2 pi, because that's our period, everything here is going to shift to the right by pi on 4. So having a look here, right, our minimum is going to shift by pi on 4 units. And not only that, our maximum up here will shift to pi on 4 units as well. So I'm going to go ahead and just put a couple of coordinates there that I know, and then from there we can just go ahead and do our curve. I'll use, let's use purple for our curve. And I know our minimum is going to be an extra pi on 4. So pi on 4, that's going to be roughly here. Maybe a little bit longer. Maybe here. How do I know that it was that distance? Well, I already know because that's the distance there. So roughly the same. Or exactly the same. That's pi on 4. So we'll call that, oh, what's that going to be? What's that? It's going to be pi plus another pi on 4. That will be 5 pi on 4. Right there. Okay. So then our maximum, well, that's our minimum there. And our maximum will be right here. Okay. Because we know originally it would have been at this position, because we know that's what it is, right? It went up by a factor of 3 and then added 2, taking us to 5, but we know it's translated or shifted to the right by pi on 4 units. So here we go. Let's see if we can make the curve. Happy with that? That's roughly accurate. I'm happy with that. I think perhaps this might be a little bit too curvy, so I could have another crack at it. So let's try it again. Happy with that. So that's how we graphed y equals 3 cos of x minus pi on 4 plus 2.